Assalamu alaikum, sir.
Walaikum Assalam. Bismillahirrahmanirrahim. In the last lecture, we started discussing the interpolation. What's the meaning of interpolation? How do we estimate unknown information from a given set of data? Uh, and for that, the first technique that we studied was Lagrange formula. Uh, I have included some part of the book chapter in order to uh, guide you that what part of the book is right now under consideration. But I'm not discussing each and every part of the book that I have included in this document, which is also there in the resources of LMS. Uh, if you are given some points, you can develop a curve with 2 points, you can develop a straight line with 3, you can develop a quadratic curve that is a parabola, and with 4 points, you can develop a cubic. A linear algebraic method of doing that is that if you have to develop a cubic, y is equal to ax square plus bx plus c plus d, then you use x in place of the input and y in place of the output, make 4 equations, and solve those 4 equations linearly to obtain the values of a, b, and c, a, b, c, and d, and write down the cubic polynomial. This can be done for any number of points. अगर आपके पास 10 points हैं, so you can obtain an equation of 9-degree polynomial. But this is not the smartest thing that we can do. Smarter things are interpolating polynomials. The first we studied was due to Lagrange formula. This we have discussed, and we have noted that if we have less number of points, 2 points, the Lagrange formula is this form. 3 points, the Lagrange formula is this form. And if you have got n plus 1 points, the n degree polynomial can be written in this form. There is an algorithm that you can use to implement this in Lagrange interpolating polynomial into a program, and that will require to input data x, I, y, I, and then you have to develop the products which are called the Lagrange polynomials, and then you have to obtain this sum. So there are 2 loops in one you are calculating a product, an outer loop where you are calculating a sum. Those who have flavor for programming or CSC students, they should implement this formula. But working with calculators or in Excel sheet, we just substitute the values in the formula. What values, and I'll describe using the example at the end of this. Here, I will skip the discussion on error analysis, which we may discuss at some point. But right now, if we are given this data, for example, and we have to use P3, that is 3rd degree Lagrange formula, to estimate the value of y or P3 at say 5.2, and now 5.2 is missing from the data, and we use this formula for with x is equal to 5/2, where we are trying to estimate y, will be placed everywhere where there is x in the formula on the right hand side in the numerator, whereas in the denominator We have to use x naught, y naught, x1, y1. जो data set may be large, and for third degree polynomial we need only 4 points. What 4 points we should use? I've discussed that, and we'll discuss again the demonstrating examples today. So to estimate a value of y for x is equal to 5.2, 5.2 lies here. So 2 points above and 2 points below, we select and work out this problem. Now, in this problem, this will be 3.5 will be x naught, 4.6 will be x1, and 8.5 will be taken as y naught or f naught. This has f2, f1, f2, and f3. All these values are substituted in this formula, and 5.2 में जब ये सारी values रखते हैं, so what you get, you can calculate this using your calculator, or you can use Excel sheet. The result when you are estimating y for x is equal to 5.2, the result should come out to be between 7 and 8.2, and you'll find out that this is around 7.6 or something like that. So I have not written the result. I have just demonstrated the substitution of the values. Yes, I have mentioned this thing. This extra space should be deleted. That interpolating at 5.2 using third degree polynomial, use 4 points colored in yellow in the above data. The reason is the range of x values from 3.5 to 6.2. एक रीजन तो मैंने पहले बता दी कि मैं 5.2 यानी इन दो के दरमियान कर रहा हूँ, तो 2 पॉइंट ऊपर और 2 पॉइंट नीचे. This facility is there for third degree polynomial. We use 4 points. तो जिस जगह इंटरपोलेट कर रहे हैं तो 2 पॉइंट ऊपर सेलेक्ट किए, 2 पॉइंट नीचे सेलेक्ट किए. लेकिन अगर मैं 4th डिग्री कर रहा हूँ तो 5 पॉइंट करने हैं, तो 5 पॉइंट में मुझे ज़रा रेंज का ख्याल रखना पड़ेगा. रेंज का क्या ख्याल कैसे रखते हैं? 3.5 से 6.2 तक मैंने डेटा इस्तेमाल किया है. रेंज बनी 2.7, एंड 2.7 रेंज जब बनी तो इसका हाफ 1.35 है. So 1.35 added to 4.5 is 4.85. Now note the distance of this mid of the range from the x value where we are interpolating. हमें 5.2 में interpolate कर रहे हैं और हम जो डेटा इस्तेमाल कर रहे हैं उसकी रेंज का मिड पॉइंट 4.85 है. लेकिन अगर मैं ऐसा ना करूं और 2.8 से 5.7 तक इस्तेमाल करूं, तो इसकी रेंज है 2.9, यानी 5.7 माइनस 2.8 इज 2.9. 2.9 का मिड हाफ जो है 1.45, जिसको मैं 2.8 में ऐड करूं. 2.9 का हाफ जो है 1.45 है, जो कि 2.8 में ऐड करूं 4.25 बनेगा. तो एस्टिमेटिंग एट 5.2 जो रेंज मैंने इस्तेमाल की है उसकी मिडिल वैल्यू 4.8 जो कि 5.2 के करीब है. लेकिन अगर मैं 2.8 से 5.7 तक के 4 पॉइंट इस्तेमाल करता तो इसकी मिडिल वैल्यू और मिड ऑफ द रेंज इज 4.85. 5.2 is sorry 4.25 is too far away from 5.2. हमने देखना ये है कि मिड ऑफ द रेंज जो है वो x के कितना करीब है. तो जिस सेट ऑफ 4 पॉइंट्स में मिड ऑफ द रेंज इज क्लोज टू 5.2, दैट इज बेटर बी यूज्ड. तो अगर मैं 2.5 से 5.7 तक जाऊं तो मिड ऑफ पॉइंट ऑफ द रेंज इज 4.25, एंड 4.25 is too far away from 5.2 compared to 4.85. So that is one point that I wanted to share. This graphical representation that is obtained using a Excel plot. X is equal to 4, we should have some value, some 7 points, more than 7.5 and less than 8. और ये जो आप वैल्यूज मैंने अभी आपसे शेयर की हैं, जिसको रिजल्ट नहीं लिखा, इसको कैलकुलेट कर लो तो दैट विल बी बिटवीन दीज टू नंबर्स. सो दैट इज ये हमने लास्ट टाइम डिस्कस किया था, लेकिन कैलकुलेशन यहाँ भी नहीं की. कैलकुलेशन आप खुद कर लिए. दिस इज टू सिंपल, जिसमें कि मैं कैलकुलेशन रिजल्ट दिखाऊँ आपको. So that was a revision of Lagrange, and let me go for the revision of next thing that we discussed, and that is divided difference interpreting polynomial. Where we first discussed what are divided differences. बुक का जो ये हिस्सा है इसको आप खुद पढ़ लीजिएगा. मैंने जो इस पे ऑल्टरनेट नोटेशन के नाम से एक नोट लिखा हुआ है, मैं इसको रिवाइज करूंगा, जिसमें सबसे पहले वी हैव डिस्क्राइब व्हाट वी मीन बाय divided differences, first order, second order, third order, and moreover the notation used for divided differences. The book that we are using frequently use this notation, and this notation is read as divided. Now note that there are 2 points, and 2 points we make 2 points, that means 2 values of x. 2 points make a straight line. So this is first order divided difference because line is the first degree polynomial. We read it as first order divided difference between x1 and x0 and x1, which I and some other literature prefer to use this notation, which shows superscript as the order of the divided difference, and subscript shows at what point we are starting. And the definition of both of them is y1 minus y0 upon x1 minus x0. That makes the first order divided difference starting at x0. The first order divided difference starting at x1 will be y2 minus y1 upon x2 minus x1. The first order divided difference starting at x2 will be y3 minus y2 upon x3 minus x2, etc., etc. How do we make a higher order divided difference? And that is notation says, now we are using 3 points or 3 values of x, x0, x1, x2. We read this notation as second order divided difference is starting at x0 up to x2. Alternate notation, superscript indicates second order and subscript indicates what's the first point used in making the divided difference. This second order divided difference is then defined as the difference of first two first order divided differences, that is